to this session, Run Scalable 4D Applications on Amazon Web Services. So my name is Balinder Walia. Some of you may know me already. Some of you are good friends and somebody you don't. So if you don't know me, I'm Balinder Walia. I work for myself, a company called JobShout. And these days I'm mostly doing platform engineering. I still am a coder. I've not turned into a sysadmin, just to be clear. But however, you will see in my demonstration that using 4D from a slightly different angle, different way, and we'll go through that. So how many of you actually were at my previous session in Portland in 2016, automatically updating 4D application? Okay, there were a few. Okay, great. So there is a way in 4D to update 4D applications code automatically, right? That's my point. So if you know that, that's fine. We'll go through it in a moment. Okay, so I'm gonna start because we have lots of things and lots of little tasks and demos. So I'm gonna get started. We already covered that. That's me. How many of you know what Amazon Web Services are, or Azure or Google Cloud? Okay, fair enough. So Amazon Web Services is cloud platform provider, which allows us to build stacks of like servers or DNS using code. So infrastructure as code. In other words, it's a platform provider. It's a service, and it's available throughout the world in different regions and different availability zones. We'll cover that. So another interesting topic I'm going to touch base on today is DevOps. And I might ask you guys if you know that already. If you know what DevOps is, that's great. Otherwise, I'll explain it. So there's quite a lot of things to touch on before you understand my demos. And so microservices, some of you guys might already know that. Automation, and that's the prime sort of moral of this session. Automation, and we'll see in the demonstrations. Monitoring your applications, security, and have some goals. It's not like the way 4D database works. So you create an application, you spin up, and out of the box, a lot of things work. This is a slightly different world. In Amazon Web Services, there are a lot of options. It's a huge service, and you will have to spend a bit of time planning. You will have to plan out your application, how you're going to migrate your application from a normal data center to Amazon Web Services or Azure or GCP. The other thing which is important, although I am focusing on Amazon Web Services in this session, but actually it doesn't matter, because the same principle and the same demos and the same idea, it applies to Azure, Google Cloud, even in your own data center, if you have your own data center. And so we will go into details, and I'll explain that. So part one is all about AWS. So there were, if I go back, there are lots of different things here, automation, tooling, monitoring, but first, so that you all understand Amazon Web Services, I'm going to cover that. So this presentation is subdivided into different parts. So before you start to think about migrating your 4D applications to Amazon or Azure or GCP for that matter, you really have to plan your network, your security. It's not like having a physical network in your office or your data center. It's because it's by default, for example, a lot of options that can be, a lot of ports can be opened, because Amazon Web Services also creates some resources by default. So that can be, a problematic. So the point I'm making is that do not use the default options. For example, VPC, Virtual Private Cloud, which is your own secure little private cloud in this huge big data center, and you want to plan it, you want to secure it from the start. Because networking is one of those things which is you can't really change after you've deployed lots of hundreds of servers on Amazon. It's painful. So have all the idea of how many servers you're going to require eventually, or your subnetting, your security. So have that all planned out. So these are a few things. If we have time, we can go through it, but they're very kind of they're very basics, how DNS and networking subnets work. IP addressing, you can have static IPs or dynamic. So all these things are pretty basic, but if we get in the demos, after the demos, we have a bit more time, we can talk about it. Excuse me, right. So the first step I said is setting up your VPC, which stands for Virtual Private Cloud. So once you set up your VPC, you have a different way of routing your traffic, your analyzing your network ports and opening up whatever ports you require. If it's a web application, you may have TLS enabled as well. So you might have HTTPS and HTTP traffic. You might have to open SSH or WinRM, which we will go into details in a minute. WinRM is basically a replacement for RDP. So if you RDP into servers manually work, I'm going to hopefully give you a better way of working remotely for Windows as well today. So WinRM basically is a SSH for Windows. So I'm not going to go through all these subnets and things in detail, but these are just for reference. You will have that slide, so you can go through that in your own time. One important point, though, you need to understand how subnetting works, the CIDR ranges work, so you can plan your host, number of IP addresses and devices, so you don't run out of IP addresses afterwards. So that's why it's important to put in there. Okay, so there's a lot of slides I've skipped, but we will come back if we need to. Another thing about VPC, before we move on, is it's virtual private cloud. You can have it per region. So VPC is set up for whole region. So if you're using Amazon in Portland, in Oregon, for example, EU, in Ireland, EU West 1, or London, EU West 2. So each of these regions are coded. And once you set up your VPCs, generally 1 or 2 VPCs, so you can set up a production VPC for all your production devices and development and staging for your dev, so you can have different configuration. Actually, one more point just wanted to make here, that you can have, by default, 5 VPCs in a region and 200 subnets, but you can talk to your AWS account manager and they can extend that if we have to. So that's just an idea of how VPC looks like, availability zones. You can have different availability zones in a region for AWS. So Zone A, Zone B, Zone C, they're physically separate data centers, obviously for disaster recovery and various other reasons. If hurricane or hits one zone, then at least you have the ability to mirror your data on a different availability zone. Generally, they're named after A, B, or C. So in this example, is one VPC. You have 3 zones, and you have your subnets within those zones. So you can create a network which, for example, 4D database running in subnet A, in availability zone A. And if you want to secure, obviously, that nobody can get to that 4D database without there's no direct access to the 4D server running there, then you can obviously have a private subnet, or you can have, if it's a web application, application, so you can open up and have it on the public network, because you will need to interact with the users outside over your network. So that's all planning the VPC and access control lists. You can have some rules like in any router. You can open some port, you can have network address translation, internet gateway. Because one of the things I found when I started working with Amazon Web Services, I launched a new instance and there was no internet on it. You will probably find if you haven't done that before. So don't worry, it's just because there is no route attached to that VPC or subnet. You haven't told Amazon Web Services that I want internet access from all my Windows machine, or I only want outgoing or different ports. So it's very important. That's why it's in there to plan that. and for security, of course. We'll get into that, data breaches and things in a minute. So typically, when you have a 4D cloud application, which is what I'm referring to here, which actually also applies to a 4D client web server, 4D client and server architecture as well as web, because you can have a HTTP proxy, for example, but you can also have the TCP proxy as well, say at the same time. So if one fails over, if you have a mirror running, all the users will be directed to your mirror. So typically the installation on the cloud is load balancers at the front, CDNs, which we get into that. I will go into also why we need a load balancer and CDN. But I'm going to use Nginx in this example. But the reason I've put all of these here is you have various options. You can have Amazon load balancers, ALBs now, they have application load balancers, more customizable. Azure has load balancers, and Google has also their own load balancers. So that's quite an important part. Okay, CDN. Some of you may have 4D applications which are open to public, and they're prone to DDoS attack, and they're prone to various other dictionary type attacks, authentication attacks, because as I mentioned, Equifax data breach is a very good example. The guys were just thinking, oh yeah, we have everything secure, and there was, I think it was a Java application where in the REST API there was a memory leak or something, and somebody exploited it, downloaded all the records from there. So this is why CDN is very important. Another very good reason to have CDN is to cache your content, static content, and divide your your application for different continents. So you may have somebody accessing your application from Far East or Europe and a different one in America. So if you have a CDN, which is called POP, it's like a point of presence, it's closer to the user and the content is cached, it will be much faster. Also, that means you're using less resources on your origin. So if your 4D server is running, it cannot cope with that much load. If the content is cached at the POP, the nearest edge, if you like, then your 4D server will not get that many hits because subsequent hits will be cached. So that's another reason to have CDN. Generally, we use Amazon. There's a built-in CloudFront, but there are other big players in the market. Akamai has been quite big for many, many years, but now it's changing. There's Fastly, and you can build your own as well if you wanted to. So there's actually an open source one called OpenResty in Lua and Nginx, which allows you to build a perfect CDN. And the Cloudflare, which I mentioned, didn't mention here, but it's all based on OpenResty. So you have that option as well. You're a programmer, so you have pretty much full control. WAF. So before you think about migrating your applications, as I said, to the cloud, and you have to really plan this and think about this because, Web Application Firewall, WAF. So WAF is very important these days, especially for GDPR and other regulations. You have to have this effectively working. So what WAF does is it allows you to configure some rules. So mod security rules, they were in Apache, but now there are similar rules available in different technologies. Allows you to, for example, mitigate XSS attacks, cross-site scripting attacks in your JavaScript application, SQL injection attacks. It can also mitigate DDoS attacks. Basically there is a whole list of rules from OWASP, the recommendations and guidelines. You can go on OWASP website and then look at all the different options you have. But that's what WAF is used for. So generally we have the CDN and the WAF at the same layer. So first layer is the CDN and WAF, and origins, your 4D applications, is right at the end. So that mitigation, if there is an XSS attack request continually coming, or a bot scraping your website for, maybe it's a news website and scraping that all the time for latest stock news or whatever, then obviously it's going to thrash the backend 40 servers. So if you have the WAF and you have CDN at the front, it's going to protect that. So that's the main reason we have WAF. So there's one question: why cloud, and what are the pros and cons for having? It's basically cost effectiveness. Excuse me. The main reason is flexibility, reliability. You don't need servers in your own data center. It's cost effective because you can work on it. You can scale your applications up and down once you have it on the cloud. And you can work on it as you go, so you scale up and down. You can work on the security. And the most important reason to move to cloud, especially like Amazon Web Services, is infrastructure as code. As I said, you plan your project, you code it once, literally like we write 40 application and code to manage business processes. That's exactly how we just say, hey, I want 10 Windows servers, 2 Linux machines at the front, and Nginx as a proxy, and I want WAF enabled. But then rather than manually going into Amazon console or Azure, or for that matter, you can just code it once. And I'll show you in this in one of the demos I have how we do that, automate that. Next, okay. Sorry, go. Yeah. Oh, sorry. Well, cons is yeah, fair point. Thank you. The cons are, well, it's as I said, like 40. You can't just jumpstart and start using Amazon. By default, it's very, very basic. There's a learning curve. There's a bit of work involved up front, but it pays for itself. It is worth it. So that's one thing. And obviously, you have to have the right tools. Amazon on its own is not going to solve all these problems. Because Amazon has some of the things that are costly. If you have an alternative, that's the reason I'm using Nginx, because it really is very high performance application, and the architecture of Nginx. So there are, you have to be prepared to learn something new, and yeah, so there's a bit of learning curve. You can't do everything in 40. You can't have WAF, or you can't have your CDN in 40, of course. So I'll go through that. So those are some of the things that come to my mind. And of course, security. If you move your application from normal secure data center in your in-house office or in-house data centers, then first thing you have to do is think about security, because it's open. So that's another drawback. Okay, this session is not really about, I'm not going to write a lot of code here and show you 40 code. That's not what it is about. This session is about changing that mindset, that way of working. And once you change that, once you know how to do, you know the right tools, you have that under your belt, then you can really make a difference. And we will go through that in a minute. And one of the terms we use in enterprises, as well as you may have heard, is DevOps. So what is DevOps? I'll go through that. That's my next topic. So it's all about adapting that culture, that change, because when you move to cloud, things are going to be different. The way of working. Like, for example, I'll give you an example. You're busy 40 application, you're making lots of changes. Your customers are asking for new features all the time. How do you release? What's your continuous integration and delivery pipeline looks like? How does it log what's been changed? How do you roll back? So all those processes. And how do you integrate with your, obviously, business management tools as well? So I think that pretty much what DevOps is, but my next slide will make it very clear. Maybe it will make you hungry as well. So imagine DevOps in layman terms, or in food, in McDonald's way, right? Every time you go to McDonald's, everywhere you go to McDonald's is consistent food available on time, drive-through, dining in, whatever. Because they defined that process. They defined that process. This is how we're going to work. This is how everybody knows. How many times you've heard, well, we haven't got staff today, we're closed. They've mitigated those business risks in the system. And this is how the development is changing, the way we work. So that's what I think the closest I can get to in layman terms what DevOps is. The way of producing quality, consistent software and deliver to your customers. That's what DevOps is. So as I said, your customers are asking for new features all the time. Your application is already deployed on cloud. And what happens over time, traffic increases, features, it becomes complex. So you have ops team. So if you have if you have separate dedicated ops team, sysadmins, then they're all helping you guys to deliver your code quickly. You may have even a lot of different sub-applications in your application. You may have a web application with HTML, JavaScript, CSS. So, managing all that process, testing. So, so here's an example. DevOps is just a general term for developers and operations to work together, rather than old school, old days. What used to happen is you just throw your code out over the wall, and ops guys, hey, what the hell? I don't know what to do with it. Or if there's a problem in production, they don't know how to fix it because programmers are the ones who have the most of the knowledge. So it's bridging that gap. So it works for any other application. You may have a combination of different applications on the cloud. 4D alone may not be sufficient for your requirements. So that's another reason to automate the delivery pipelines. So over time, ops maintain reliability, and they do juggle a lot of things. There's a lot of servers. You have hundreds of servers. So I helped a couple of 4D service providers, 4D software developers, to launch their products on Amazon. And within months, we had hundreds of servers. And then it becomes painful to manage those servers. And of course, you can afford sysadmins, and you have Windows DBAs, administrators, 4D DBAs who are doing all the work. But what is the value of that, especially in eyes of your customers? So we'll look at that. So that's why we really want to think about building those tools. And that can be done in 4D as well, which I'll show you. So this is, again, just to wrap it up, DevOps. You have your developers, you have your build, test, release, plan, monitor. That's this continuous cycle of, that's the way software development lifecycle looks like. Your customer asking for new features, feedback, business wants more efficiency. But the anything done in between before it gets to your customer, the new features, is actually, that doesn't have any value for customers. That's just extra time. They always, well, when can I have a feature? We always ask 4D. Well, it's not ready yet. We want it now. So that's the way of software, the work. So that's another kind of what is software development lifecycle, and why we need to change the way we work and have DevOps mentality. So first thing is microservices. So even if it's 4D big monolith app, break it into different systems so you do not take everything down when you want to release something. You have that microservices built into your development lifecycle. So for example, you send emails or messaging, you may have integrated with notification systems. You don't have everything in one big monolith app. That's one change, quite a big one. A lot of companies have done. I don't know if you know Netflix, there's a case study from Netflix, how their entire, even if the entire AWS region or availability zone is down, it automatically, while people watching Netflix, streaming videos, without any delay in the session. It just shifts from one data center to the other. So that's pretty amazing, yeah. That's why they can offer, Netflix offers pretty reasonably priced services. Okay, because they've automated everything. Oh, actually, sorry, one more thing, APIs. So accessing your data for the application, definitely go down the route of having APIs, obviously anywhere you can, if it's possible. Getting your access to your data from cloud APIs also makes it more performance-wise, it's a better way rather than accessing over SQL, for example, opening lots and lots of ports, which is a security issue. So have it all kind of planned out. Okay, we already been through that, most of this. Goals, have goals, guys. I found it, when I started down this route, sort of changing the mindset from writing code all the time and doing all the admin work manually, I was like, no, I have to be determined. I'm going to automate. I'm not going to manually go and manage those servers or update Windows patching. So I'll show you in a minute. Right, next is, so I've already mentioned for the auto update command was the kind of the first step towards automation. So all the applications can be automated wherever they are remotely, and that's already in the last session, and that's kind of an extension of it, because then I realized that what about Windows? What about the operating system? What about the other things? Okay, great, we can have 40 applications up to date all the time for all customers we want to control, but what about Windows? There's a security issue from Microsoft, and you need to patch all your hundreds of machines all of a sudden. What are you going to do? So, excuse me. Yeah, so that's, there's a term for that, continuous integration and continuous delivery, so making changes, testing. That's the nature of this beast. Again, there are various methodologies we can use to deploy. You can have rolling deploys, you can have, maybe you have a mirror or a testing site for your application, and you can say, well, first deploy there, run some automated tests. Once it's successful, then you move. Or test live, test in production. But to have that, I still remember I have this like, if debug enables, then show me more information. From one IP, you can see a lot more detailed information. But that's the way to do it, because, yeah, you're not going to be able to replicate, especially for web applications, the scenarios in a test environment. So wherever possible, work in prod, test in prod, do A and B testing. So you can have, there is rise and edge computing these days, so you can have even, for example, JavaScript running only in one continent. So you can say, all my customers from America see different version of the system. I'm going to roll out in the US first, and then afterwards Europe. And so you have that ability once you have the right tools. Of course, reputation. So it's data. You're hosting databases. If you are, then it's it's a big responsibility. So that's why we need to automate this. Sorry, agile. Okay, that's all. It's all good stuff. There's only one thing: have 2 pizza teams. Normally, what 2 pizza teams means is you can feed the team in 2 pizzas. Don't have a very big team. And the reason for that is it's like, any other software development process. You do not want to have a very big team and have goals, so everybody's on the same page. They know what our goal is. Right, monitoring. So once you move your applications, 40 applications to cloud, one of the most important thing is analyzing the application logs, analyzing what is happening, because you may be actually having too much of compute power or RAM, for example. You don't need it, and if you don't need it, scale it down. Your application, may require more hefty computing only on certain days. So there are ways to deploy and set up that configuration so that, and by monitoring, of course, but you can integrate monitoring systems with your actual, what we call it is configuration management systems. So I have in this presentation a demonstration of how we can use 4D as a CMDB, which is configuration management system, like an inventory database of all our resources on the cloud. So we'll go through that. And one of the tools I'm using, there are many tools available to automate. You do not want to write, as I said before, trust me, I've been there. You do not want to write all the different APIs to manage DNS, manage S3 buckets, manage resources, EC2 instances. That's just a lot of stuff. And you know, use something which is already there. For example, Ansible, Chef, Puppet. They are the big is one of the biggest from the three. Ansible is very simple and it's cross-platform. The reason I have chosen Ansible is that you can use Ansible to not only manage Linux machines if they're running in front of 4D, you can automate the Windows servers as well. So for example, you want to apply automatically Windows patching on certain servers, you can do that. You do not have to log into RDP, which I will show you in a minute, using Ansible. There's another really good reason to use Ansible is that it's YAML format. It's literally configuration in plain English. Anybody who's taking over your project or a sysadmin guy is working with you, they can just read that. You know, it's defined as plain English. Okay, you know, do the Windows patching on these set of servers. There's another very good feature of Ansible, grouping of your resources. So you can have servers for your customers per project. You can say all my Windows servers or my Linux machines in a different group. You can say the US customers, UK customers. You can group your inventory, which I will show. So that's another really good and batteries included approach, which is, it's really easy to get up and running and started. I'll show you in a minute. It takes no time, a few minutes to install it. It's cross-platform. It works on Macs as well, by the way. I will use it on Mac. Ansible modules. So there are lots of modules already available to patch Windows, to patch Linux, Amazon Linux, to Red Hat Linux, Ubuntu. There are nearly 1,400 modules available to change Route 53. So imagine your monitoring system detects, hey, that 4D application is not responding anymore. Take it down automatically. Change the Route 53 to point to your mirrors or failovers. But with Ansible, it's all in there. It's already available. Okay, so the other is Nginx module because we are using Nginx in this. As I said, you can use any technology, any web server. It doesn't really matter. I've just picked up one, and it's very much like 4D plugins. So just to understand how it works. Okay, next. So that's an example of a task. Provision EC2. I was going to show you, but there are so many demos, I can't show you everything, so it's just listed here. So this is an example of an Ansible role where you have your role to provision EC2. So you want 10 EC2 machines, Windows machines, and then it will return you the response in JSON, which you can parse in 4D and have your inventory managed centrally. So that's just an example. I can use different templates as well. I'm using process 4D tags to process my configuration files, and I'll show you, but there is a built-in processing and templating engine as well in Ansible. So that's typically how it looks like on the cloud. Your CMDB in this case is 4D, and your users obviously accessing, making changes to inventory. You may have sysadmin guys, you're looking after your inventory, you know, your servers. That's kind of a architecture how normally Ansible works. So tooling, basically that covers Ansible in this case, and CMDB. So have those tools, you know, have those tools deployed once so it makes your life easier and you can automate. Demo time. I know. It wouldn't have made any sense if I go to the demo straight, because I'm using all these tools and you wouldn't have understood. So there was a reason why I had in the end. Okay, and you can use this using as much as in 4D plus open source. So that's the idea. So there are two demos here. One is the actual CMDB running on my Mac, which is my inventory database, for example. And I will show you how that works. I'll go through quickly, whiz through the functionality of it. The second application demo is just running on AWS Windows machine. So that's the actual, imagine that's your 4D application on the cloud. It's web-based, okay? So there are two demos here, and they are on your 4D Summit USB drive as well. Okay, so these are the things I'm going to cover in the first demo. So we'll see how these playbooks, which are Ansible scripts actually, they are written and managed by 4D. So I have a 4D database where I save these as templates. And then the reason for that is we want to reuse the code as much as we can, possibly. We don't want to create separate playbooks for different servers and, it's just one playbook, but we just reference which group of servers you want to work on, and I'll show you how. So that's the reason we have playbooks. And it can manage, as I said, it can manage the Linux machines as well as Windows at the same time. So if you have Nginx running at front on a Linux machine, and it's part of the same project, so you can deploy the entire stack with the click of a button. The other useful feature of Ansible, which I'm using, is tasks. But I have the tasks in 4D database. So 4D passes those tasks, whatever needs to be accomplished, to Ansible, and Ansible does the thing. The reason that we did that this way, because we don't want to write everything in 4D. We do not want all the APIs, as I said, written in 4D to accomplish those things. It will take forever. So I'm going to open up the demo and switch to my screen with the demo. Okay, so that's the CMDB, which has services. This is my project, basically, my projects. So in your case, it could be all your different projects and applications deployed on the cloud already, or you may want to deploy, you're not ready yet. So services, just to show you what it looks like. It's just a very simple database of, I have, like 4D Summit, that's a service. It has stacks, so I have named them so that it's easy to understand. So we have update 4D servers. It's basically, if I expand it, if I expand it, it will make more sense. 4D Windows servers, and that's a stack. So that stack can have, it's basically like a group. So that can have all your Windows servers, or you can have just one stack per project. And another one is here in this example is 4D Summit demo HTTP server. HTTP server, that's the second app I have. So that app, imagine my EC2 instance has died for whatever reason. It's crashed or 4D crashed, whatever. What are you going to do? You're going to log in manually or restart? Fine, but if you have 10 instances of it, then it's going to take you a very long time and your system could be down. So that is a playbooks, a combination of playbooks. Stack is a combination of playbooks, which will allow you to deploy that application on any new instance with everything from 4D licenses to copying all the files you need and the latest data file. So if you define your latest data file backup where it is, it will pick it up from there. So that's that. And finally, there's a screen for logs. I'll show you when we run this. So just before I run that, I want to show you some of the configuration playbooks, what they look like. So provisioning EC2 instance, just a pretty small file here. And it's pretty straightforward that, I want EC2, use EC2 module, and I want to spin in this region, instance, EC2 region. These are all variables, by the way. They can come from 4D, and I'll show you how. So that's an example. Another example, as I mentioned, put Nginx cluster at the front of 4D. So you may have a CDN built in Nginx. You may have your Nginx proxy as a load balancer, but you want to define that state in one playbook. Because remember, the whole point of this is infrastructure as a code. You just want to have a contract with this, your cloud provider. You want, it's just with your big, huge computer data center. It's one big computer, right? Imagine. You just want, I don't care, where the instances you get, where the resources are. I just want you to run 10 instances of those for this project, 2 instances of Nginx, and I want an RDS or 4D database, whatever it is. And you just have that contract defined with the system. So that's the kind of analogy I use. So if it's a Linux, you have update all your Linux servers patching. And the 4D platform, 4D is running on Windows, so that's an example of a playbook which will allow you to configure which OS the updates you want to run and when. So in the actual services, there is this is a 4D database, so you can obviously modify and change whatever, but I have like a run level that run all the time. So that just every day or every hour, I can define in the configuration that Windows patching I just want to run every time. However, in the playbook, I can say that when you're running this, there's a variable available. It will tell you if the reboot is required or not, which is pretty important. Because if you have lots of restarting, servers restarting, excuse me, you may want to update 4D on the first 2 because you don't want to bring all of the servers down. So you can automatically bring the 4D server down, apply if the patching requires reboot, of course. If it doesn't, then you don't have to. So there's a complete programming control available in these playbooks. So actually, I'm just going to run one of these. Actually, there's one more thing. These playbooks can also use tasks. So I just quickly go through tasks as well. So here's an example of a task, copy file. So you may want to, for example, update all the 4DC files on all your servers. You could do that if you want to. So 4DC file is just to update your application, right? That's the quickest way to update. And you don't have to do it manually. So that's an example here. I have, if I search for actually 4DC, should be able to find. So that's, oops, sorry. It's a playbook, I think. Yeah, so sorry, it's a playbook which calls just a module. I didn't have to create a task for it. But you can create a task, for example, to copy files. You may have your configuration, a backup configuration, which somebody can accidentally change backup configuration on your Windows servers for 4D. And yeah, so you can run a task via playbook every hour and make sure if it's changed, change it back. Somebody might open a port accidentally, 19813, so your 4D database access is freely available. Somebody might change a password or something on the Windows, and you can enforce that. Remember I said that contract. You can enforce that with these playbooks, these configuration files. You can say, I want my system state that, and if anybody changes it, change it back to what my business wants.
Now, what is actually doing the work that this playbook defines? Is Ansible running on the machine and is actually
All right.
doing the work, or where are you sending this message to?
Okay, that's a very good question. I was going to come to that, but yes, it's a good timing. So Ansible runs on my Mac as a single binary. And there are other tools in the market, which is like Puppet and Chef, but they require you to install agents. Like Amazon Web Services have their own SSM agent, System Manager. It will allow you to do the same things. But Amazon's SSM and other tools are actually more work. They're complicated. Ansible is just simply running on your machine. And it remotely, what it does is it creates a Python bash file combination for Linux, pushes that and runs it. For Windows, it runs a PowerShell. It generates a PowerShell file, pushes onto the machines and then run it. So it's really simple. You don't need anything extra. You already, SSH is already configured on all the, I mean, you know, we have thousands of servers in my company, and they're already configured with the keys to log in. So you don't need to make any extra change. You just define those, and it will run. And for Windows, it uses WinRM. So we don't use RDP. It uses WinRM, which is Windows Remote Management. All you have to do is bake that in your AMI or images, that whenever I spin a new instance, Windows instance, it must have WinRM available. That's it. So you don't have to make any other changes, which is only one step. So once you're done for one, and if you spin hundreds of instances from it, then it will all be, the WinRM, it's like SSH basically, and it will be available. Yeah, question?
So the PowerShell script that this creates,
Yeah.
that ends up running on the Windows server
Correct.
at some point, might command WinRM to do some things and do whatever's necessary.
Absolutely.
So PowerShell, so you said there were 1,400.
Modules.
Yes.
Yes.
Where are those modules? Where do they live?
Okay, Ansible Galaxy, most of them. There's a website called Ansible Galaxy.
And they are part of the Ansible program that you're running here. That are you?
No, you could just enable, well, just like any other package manager, you know, you could just say enable this module. If it's not available, for example, especially when we are configuring Windows modules, you may need WinPy, because it's a Python project. So Ansible is written in Python. It's open source. And in fact, there's a database like CMDB like this, which is also open source available, but that's web-based. I wanted to deliberately, I've done this in 4D to show you guys that you can create your own interface and link it with Ansible. Because it's JSON API, so it's just HTTP or socket-based API. You just interact with it like any other system. It's standard. So is that clear?
Yeah, let's see it work.
We'll see how it works. Okay. Actually, let's just run a playbook. And so you can run 4D Summit demo, for example. It has no domains because it's just using IPs. One thing I forgot to mention is that I have all the servers inventory here. So all my servers are here. So these are the two Windows servers where 4D is running. And let me just show you a web browser to show you. So that's the application running in Amazon. That's a 4D database, web application, via Nginx. So if the entire stack, as I said, goes away for some reason, as long as I have all my backups, I can restore it within 15, 20 minutes. And it's an immutable infrastructure. So it will be new machines. Every time I want to bring it back up from disaster recovery, it will be new in Windows machines. It will be new Nginx. Everything will be new. But it will work exactly the way because it's defined in the configuration. Can't change. Okay, so actually so let's run this. Make it bigger. Fingers crossed. Because we have had some Wi-Fi issues before. WinRM port was closed, wasn't working, but let me see what happens. So I select, oh, sorry. There's a message on my screen you don't see, but it's just I have to reselect that. Okay, so it's giving us some output straight away. So there's a little bit of a delay here because it's obviously creating that modules and files, whatever it needs, to do the patching on Windows, and it will return the result back. So that can take a minute or two. But I have defined all these critical Windows up patching, for example. So while it's doing that, okay, it's done that, I think. Let's see what the result is. So there was no change made because all the Windows machines were up to date, patched, but otherwise it will indicate here change, and that's in JSON, and that's available in 4D as a variable, so you can parse it. I actually just for this, I just kept all the history of all the playbook runs before. So I just wanted to show you that I've been doing this because just in case demo didn't work, I could show you what happened. So I have been using the playbooks to, actually I'll run it, it's easier. So I have actually real customers, this was a 4D database, but now it's running Nginx at the front. It was a 4D web server before, a long time ago, nearly 10 years ago. They have 1,000 hosts, and they all have to be HTTPS for compliance and whatever reasons. So this playbook, which I'm running, it checks everything that is this site up and running or not? If not, it can bring up EC2 instance and deploy all the configuration. Then in there, let me see if I can switch. Okay, yeah, we have to wait while it's finishing, but let's just look at the result. You see, it has checked all those hosts, and if any of the hosts' SSL certificate is expiring soon, it will renew. So these are the type of things you can automate. So 1,000 SSL certificates. They are deployed automatically, they are renewed automatically, and yeah, basically, I don't have to worry about SSL certificates. It can work on Windows as well, of course. And I'm using Let's Encrypt for this. So the result of that playbook is, how much time do you have, Vance? 10 minutes, okay, great. So as you see that it has said there was 3 servers, 3 nodes, 1 failed, and I think that was just because maybe I don't actually have an SSL certificate on that machine, but it just tried to renew it, but it just failed, so that may be just something simple. But all the 2 other instances, which is Nginx at the front, running, and the TLS were checked, and nothing has been, yeah, there's no problems. It would renew it if there's any SSL certificates. Needs renewing. Okay, what else do I do? Backups. So I run Ansible scripts to do all my backups. And not only just 4D backups, even if it's a 4D backup, I can trigger it from shell, PowerShell. Because I want to make sure that it actually has happened. I want to then verify it's on S3, because all the backups go on S3 for storage, is to manage resources. S3 is really, really cheap, and EBS volumes are just not for that. So these machines have pretty much 20 gig of storage, 8 gig of RAM for 4D, and for the Linux machines, any guesses? T2 Nano, basically the smallest instance you can get. So I'm running these, actually there is another picture I would like to show. If you just give me 1 minute. So this is how we save cost. It's all about saving resources. So I'm just gonna, this is also something you will get as part of this. It's something I've written. But this is a product for News Corp. It doesn't matter behind it's 4D or PHP, whatever it's running, but the important thing is it's all running on T2 Nano, 6 T2 Nano machines. 50% of the traffic on Times website, The Sun, various other Dow Jones, is managed by this. Basically, anything which is not in a CMS, any URL which is not found, it gets redirected to this cluster. And this is self-healing. It just never goes down. It just brings itself back up in a different region. You can configure it, and that's all done by Ansible. So
is Ansible a command line program, or
it is a command line only, but yeah, that's why well, the reason I wrapped it up, because I thought it will be more easier for you guys to understand. So when I actually press any of these, so if I go back up, it actually shows you, let's scroll up. So it's just running a playbook here. It's going to show you, there you go. So that's it's created a bash file to renew all the certificates or install. If the certificate says not there, it's missing, it will install it. But that's just running a playbook, an example of a playbook. So that's called renew Let's Encrypt TLS cert. So in case of Windows patching, if I just go back and rerun it, you will see that it's just going to run a playbook somewhere, which you can run from command line as well. So in many cases, we have Ansible running on EC2 instances itself, not on Macs, because in companies like we don't run from our Macs. It's all remote, and we can execute those commands remotely, and you can also do that from 4D. So I'm just running simply those commands. I'm generating the templated files, whatever I need, the whole configuration, creating that playbook on the disk, and telling Ansible to run it.
Launch external process, do that.
Yes, absolutely. Yeah, launch external process. Absolutely. So you see that is, oh, actually, by the way, there is a way you can stop so you don't gather all the information about the system, but that's just for the demo. So I have all the, what is it, Windows Windows Server 2016 data center, reboot required, but that's. Okay, so I have more demos. I can literally, if you want, I can show you later on one-to-one. But like, for example, bring back 4D on a different Windows machine in a different region, set up as a mirror, and tell Nginx to also point all the traffic from like different continent to that machine. So you can just do that all in one go with press of a button. These tasks, the reason I have divided into like smaller tasks, because I just want to reuse it. In fact, in the task definition, there is a way to see that this task is used in this and this playbook. So you have this many-to-many relationship. You have this stack, but Windows patching playbook can run for different stacks, but you only go and change one place where if you want to change, so that you can easily maintain that.
And this what you're showing is on the USB key?
That is on the USB key, sir.
And for free?
It is for free. In fact, I tell you what, I have a GitHub version which I constantly update because I'm making changes whenever I can. So it's always, you are welcome to contribute and work with me, or just download the latest version every time. This is done in a day. This is not a big deal.
You built this in a day?
Yes, this is just for demonstration. So it takes 5-10 minutes to install Ansible. Then I thought, well, first of all, I was going to actually show you why running shell commands or terminal. But then I thought, oh God, okay, terminal, yeah, in 4D Summit, it may not be a good idea. That's why I built this. Any questions?
How did you send a message to the 4D server to tell it to back up? I mean, certainly Ansible doesn't know anything about 4D or 4D server.
No, you can just write in using modules, you can say run this shell batch file or a PowerShell script, and that can call 4D. Or you can even just say, you can create, like, for example, in actually some cases, I even created a URL, which is only authorized to ping from my office to create the backup. So in Ansible, there's a curl module. So you just say, run that every hour. Because it curls, it pings, it does the backup. But then you can verify that as well, because you can check S3, has it got the latest files or not? Yeah, it's pretty organized, actually. You can delete the old ones as well, or archive to Glacier, because you don't want to keep like backups for days and days. We have backups for every hour for some sites. We just, we dump it back onto Glacier after 7 days, I think, and then it just releases all the S3 storage. It costs like, this project I was showing you, any guesses how much this costs? The one I was showing you is a cluster of 6 Nginx servers. Doesn't matter, they're running WordPress, they're running different sites behind it. But this 62 Nano with one Redis, a cluster of Redis. Redis is just a caching database like Memcache, for example. It's called Elastic Cache. So it costs News Corp $60 a month. Because it's running on so small compute. In fact, when we move it to Docker, because Docker will even give up more, it's more faster to boot, and in Docker world, it'll be even faster and cheaper because it's more condensed. Because Docker will use one OS image to reboot all these instances. But at the moment, we use AWS Code Deploy. So if I want to change the code, this has got a bit of Lua. There's one Lua file as well. I don't know if you know Lua. Lua is the smallest language. It's built for embedded devices. But for server, it's great. So we have the WAF built in Lua. So WAF, the way it protects for this site I was showing you is, for example, if I wanted to do an XSS attack. So there's a foo URL, which is, I don't know, foo, I think slash. So if I have a URL like this, so it's working fine, but somebody wants to do, let's say run JavaScript on your site. Sorry, not as alert, it's just alert. So I just say hello or Merry Christmas, whatever. That has blocked my request before it even gets to 4D. Because somebody's trying to have an XSS attack on somebody's trying to run a JavaScript from within our web pages, which isn't an issue if you just have an API. So Synergist in UK, they use this technology to deploy. They have nearly 100 now, Windows Server doing 4D, and because they migrated to cloud completely. And Welsh Harris, Senko.cloud, you know Tim, he's using that. So I'm managing all of this with Ansible for him. So there is already 2 case studies. Use this technology. Hi, sorry.
Do you have any tips on actually deploying a 4D client server database in the cloud?
Tips, well.
I mean, you know, where the client is not on the user at home, but it's also.
Right, I see. So you have the 4D client on the cloud as well?
Yeah.
Right. Well, I mean, in Ansible, there is a very easy module called, it just downloads packages, installs 4D wherever it needs on all the servers. So you can just configure Ansible script once, probably half an hour to an hour's job, and then run it. It will install 4D clients on a group of clusters of the machines you want. And if you want a server, you just have to put in a different group. So I will show you the inventory file later on, because we're running out of time. But that's just a way of grouping which is a 4D server. You can do by IP as well if they're static IPs.
Basically what you do is on Amazon, you configure 10 virtual machines.
Right.
For the client, and then one virtual machine that's the server.
Right.
And you tell them to work together and have the storage and all the things they need.
Yeah, anything which can be done using PowerShell. In fact, anything which you want to achieve, you will probably find there's a playbook and a module already. Anything which you can do from command line, it's achievable from Ansible, because it's at the very low level. It's SSH access or WinRM. So I use for one side now, configuring firewall rules. I have just defined in 4D database all my 4D ports, 198.1.3, whatever. And they're only allowed to, remember, if you have a VPC and if you have private network, your 4D server is secure, you only want to allow those 4D clients to connect from another, maybe same VPC, same subnet. You don't want to open public. So the point is that configuration is all defined in one file. So don't allow any traffic from outside world to these 4D servers or clients. But allow the downloading of files from that server. So all these, all the business requirements.
No, I was rather thinking about something like you have Citrix, for instance, where the
Right.
user from home can actually work on a remote machine.
Right.
And have the same client experience as you would have in a client server setup.
Sure, once I haven't done it, but once we know all the requirements, it's pretty, because that's why we use Playbooks, because they're like your documentation. They're what your requirements are.
So do they then do a sort of remote desktop?
Yeah, WinRM is a way to control anything on Windows remotely. It's like SSH. Do you know what SSH is? Yeah, for Linux, but that's the same thing for Windows. All right, thank you guys. Hope you really enjoyed it. Thank you.